Saturn, a world encircled not only in majestic rings, but in an array of moons that have been likened to a solar system in miniature. It is the sixth planet out from the Sun, and the second largest in our solar system. In 1997, an international mission was launched to Saturn that would, for the first time, attempt to place an orbiting spacecraft around the planet and land a probe on a moon in the outer solar system. Standing 3 stories tall, there was no disguising Cassini's size. It remains to this day the largest U.S. interplanetary spacecraft ever built. When fully loaded, it will weigh 12,500 pounds. After a journey of nearly 7 years, Cassini and the Huygens probe are nearing Saturn's doorstep. The flight path will take Cassini and the probe up through and back down a gap in Saturn's rings. Cassini's arrival coincided with a time when the planet was well lit by sunlight, providing extraordinary views of the rings.
Saturn plus the rings span about 250,000 miles, and they would fit in between the Earth and its moon. And yet, for all of its wide expanse, the rings themselves are paper thin, only about 10 feet thick. If you could scoop up all the ring particles, they would be less massive than one of Saturn's small moons named Mimas.
From a distance, the rings cast off a sense of serenity, but they are as complex and chaotic as they are beautiful. For they are made up of countless numbers of disorderly objects of different sizes and shapes. This is a simulated image based on radar observations showing particle sizes found in different regions of the rings. The color purple represents where there is a preponderance of objects smaller than 2 inches. Particles in green are about 1 inch in size. The bluish bands are still smaller. The white bands are dense regions that radio signals were unable to penetrate. This false color image highlights what can be seen in the ultraviolet. The turquoise colors represent water ice. The red colors are a different kind of particle. Uncertain as to what it might be, the scientists decided to name it dirt.
Cassini was also able to measure the temperature of the ring particles, and the rings that had the most dirt or pollution were slightly warmer than the bright, icy rings.
And despite being made of mostly cosmic dust and ice, the rings contained some structures as large as a house, and as scientists discovered to their astonishment, even transitory mountains.
There was a unique moment in the Cassini mission where the sun was edge-on to the rings, and that allowed us to see anything that would stick up above or below those 10 feet thick rings. Then lo and behold, we found what looked like mountains casting huge shadows on the rings. And it turns out that the rings of Saturn are not like just individual particles, but a lot of these particles stick together and grow into larger and larger particles. But these clumps of particles are ephemeral. They don't last for a long time. They can be broken up and then reformed into new particles.
Saturn's moons and smaller moonlets also influence the rings. Even orbiting rubble piles hold a kind of sway. Altogether, they help shape the boundaries of Saturn's rings, herding in particles that might otherwise rain down in a torrent on the planet or escape into deep space. Meanwhile, particles from some of Saturn's moons are constantly shedding off, helping to preserve existing rings or creating new ones. Among the unexpected discoveries within the rings were these propeller-like objects.
propellers are these largest clumps of ring particles, and they get big enough so their gravity wants to push apart the rings and open up a gap. And then there's not quite enough gravity to open it up all the way. And so you see these little propellers sprinkled throughout the rings, especially in Saturn's A ring.
A mystery dating back to Voyager was the appearing and disappearing of ghostly spokes. Cassini determined their cause: electrostatic charges that lift up dust particles where they levitate for a time above the rings. There remain two fundamental questions lacking definitive answers. The first is knowing how the rings came to be.
So many things about the rings are unexplained even now. There are a lot of ideas for how Saturn's rings initially formed. One of those is that perhaps the rings formed from the material that was left over from when Saturn formed. So if that's true, then the rings are old as Saturn itself. Other ideas say perhaps an object, maybe a comet or a meteor, came in too close to Saturn, was torn apart by Saturn's gravity, and then created the rings. Or perhaps a moon wandered too close to Saturn and was torn apart. And so then the rings could be as young as maybe only 10 or 100 million years old.
Along with determining the origin of the rings, understanding their fate is also an unanswered question. But the adage that nothing lasts forever likely applies even to them.
As micrometeoroids continue to bombard the rings, and some of the innermost particles fall into Saturn and actually water the planet, the rings are getting lighter and lighter with time. And so perhaps in another few 100 million years, Saturn's rings as we know it might be gone. Maybe we'll be left with narrow rings like we see in the Uranus system.
With Cassini safely in orbit, science takes center stage. Beginning with a dramatic descent of the Huygens probe to the surface of Saturn's moon, Titan. Titan is the only moon in our solar system having a dense atmosphere made mostly of nitrogen, just like the Earth. There are smaller amounts of methane and ethane that break down into organic compounds, creating the moon's smoggy orange haze. Titan's extremely cold temperatures turned some gases into liquids, which led scientists to wonder, could Titan have oceans, made not of water, but of liquid methane and ethane? The Huygens dive into Titan is the most distant landing ever attempted. The descent through the atmosphere is expected to take more than 2 hours. The hope is that the probe's batteries will last long enough to reach the surface. What it will be like, no one really knows. Because there could be lakes or seas of methane, the probe has been designed to float. After surviving the initial phase of the descent, the first of 3 parachutes deploys. Nearer the surface, the winds begin to calm, and Titan's orange haze begins to clear, revealing below a surreal landscape.
So imagine descending down through a misty, cloudy atmosphere, and suddenly below you breaks this vista of this very bright hill with channels that are carved by liquid, with rounded pebbles that were evidently rolled and tumbled by liquid. That was what the Huygens probe saw, and it showed us that methane not only is in the atmosphere, but has been raining and producing weather and carving features in the landscape for long periods of time.
What Huygens sees seems to resemble a dried-up riverbed. Right in front are rocks made of frozen water, harder than stone. There are no signs of lakes or seas. But Huygens' view is only a single spot on a moon larger than the planet Mercury. The global reconnaissance will come from Cassini. On many of Cassini's orbits around Saturn, the spacecraft will fly near Titan, allowing navigators to use the moon's mass to alter trajectories while at the same time conserving fuel. These flybys are also opportunities to use Cassini's powerful radar to penetrate through swaths of the moon's hazy atmosphere. The radio waves that bounce back from Titan's surface can be turned by scientists into topographical maps. Piece by piece, swath by swath, Titan is revealed. A large dark basin turns out to be a lake full of methane. It is the first of hundreds of deep lakes and seas that will be found. Massive dunes are seen, made not of sand, but of organic molecules containing carbon. Titan's strangest discovery is a continent-sized area named Xanadu. Here are canyons and mountains that resemble no other place on this moon. Titan may even have volcanoes that gush out an icy mixture of water and other materials. And this water comes from a hidden ocean beneath Titan's icy shell. And whenever water is mentioned, it's not long before the question is raised, is this a place that could possibly support life?
Giant Titan, the size of the planet Mercury, has a global liquid water ocean underneath its icy crust, as well as methane lakes and seas at the North Pole. And we wonder, could those methane lakes and seas support a different kind of life? So that's really opened our eyes.
There's still more that was discovered. This moon has weather and seasons. Here it rains, not water, but methane that floats down like snow.
It's so Earth-like that this is a very familiar place. The chemistry in the atmosphere is much more complex than expected, and the system as a whole is just as intricate as Earth in terms of the atmosphere interacting with the surface and the materials on the surface. Titan has a methane cycle just like Earth has a water cycle. And being able to watch that in action, seeing the lakes on the surface, the channels that have been carved into the surface, and then actually seeing clouds forming in the atmosphere and rain, the effect of rain on the surface. That whole cycle has been one of the things that's been absolutely spectacular.
Saturn's moon, Enceladus, was also a target of special interest for Cassini. It is the most reflective object in the entire solar system. And a great mystery was why this moon seemed to have so few craters. Theories abounded. Might there be some internal heat source that melts ice on the surface, which then fills in the holes? Could volcanoes or geysers account for the moon's shiny facade? Or was Enceladus just a dead, airless ball of ice? Cassini would find the answer, sending shock waves through the scientific community, all of it brought about by one of the spacecraft's least known science instruments, the spacecraft's magnetometer. It's a kind of high-tech compass that makes measurements of magnetic fields. It's so sensitive that it can even detect the spacecraft's own magnetic emissions. To cancel out those unwanted signals, this instrument was marooned out on the end of Cassini's long boom. On this flyby, no one was expecting there would be much from the lonely instrument. The expectation was that Saturn's magnetic field would extend straight out and flow directly through Enceladus. Instead, the magnetic field was curving around the Moon. There were also unexpected signs of ionized water vapor molecules. These were measurements that could be translated into sounds as the spacecraft approached and departed from Enceladus.
And so it was clear that there was a source of water group ions in the vicinity of Enceladus. And in addition to that, there was something strange going on in the magnetic field. It looked as if Enceladus was a much bigger obstacle to the flow of plasma and field coming from Saturn, that there seemed to be something in the data which was pointing to an atmospheric signature of some kind. And at that stage, we were talking about an atmosphere covering the entire surface.
Not everyone on Dougherty's team agreed. For one thing, tiny Enceladus lacks enough gravity to hold an atmosphere in place. In hopes of solving the mystery, Dougherty proposed flying even closer to Enceladus on the next flyby. Navigators plotted out a new course that sent Cassini skimming just over 100 miles above the Moon. In the southern polar region, Cassini found the landscape free of craters, yet littered with house-sized boulders of ice, carved out along bluish trenches that scientists dubbed tiger stripes. The Moon would no longer be known for being smooth. Here was a fractured surface, containing crisscrossing faults, folds, and ridges. These crevices tell us that Enceladus is geologically alive. From these fissures, more than a mile deep, geysers are erupting. Nicknamed Cold Faithful, they are continuously spraying out massive jets of ice particles and water vapor. The speculation from more than a decade before that the shiny surface of Enceladus might be the result of ice volcanism turned out to be true. The detection of geysers was stunning, for it meant the existence of liquid water near the surface of this bitterly cold moon. And that turned Enceladus in an instant into a prime target for the remainder of the mission. Previous plans were tossed aside in favor of adding more Enceladus flybys, including dramatic plunges through the plumes. Enceladus is as small as it is bright. This small when compared to Earth and our Moon. Given its diminutive size, it was thought Enceladus would have long ago lost any interior heat. And what, scientists wondered, was causing Enceladus plumes to spray out these hot spots? The answer involves Saturn's massive tidal forces. They create friction inside the Moon's interior, where there exists an ocean of water, a tremendous discovery. And liquid from this ocean wells upward, creating the Moon's hotspots and the geysers that vent out. And from these plumes, scientists discovered that the Moon's ocean contained salts and complex organic molecules, likely created by hydrothermal vents, the exact conditions believed to have given rise to life on Earth. For many, these discoveries about this tiny moon was Cassini's biggest triumph. For Enceladus is now one of the most promising destinations to search for life elsewhere in our solar system. When science fiction writer Arthur C. Clarke wrote the classic 2001 A Space Odyssey, he chose for the book's final scene Saturn's moon Iapetus. What Cassini saw at Iapetus was breathtaking. Many of the observations focused on examining a mountain ridge on the equator that contributes to the moon's unusual walnut-shaped appearance. These mountains, made mostly of ice, are among the tallest in the solar system, soaring 12 miles high, more than twice that of Mount Everest. Scientists have more than one idea as to how they may have formed.
One thought is that perhaps when Iapetus was more fluid or pliable, it was spinning very, very fast. And so it sort of bulged out at its equator as it was spinning. And as it cooled off, then it held that shape, actually had that mountain range going around it.
While the bulge remains to be solved, scientists believe they are on more solid ground as to the reason why Iapetus is so starkly black and white.
One of the puzzles going all the way back to Voyager is that dark material coming from inside Iapetus, maybe some kind of volcanic eruption, or is it coming from outside? And Cassini solved that puzzle. Turns out that there's a captured moon Phoebe in the outer part of the Saturn system. Dust from Phoebe comes in and it gets swept up onto one side of Iapetus, coating that side in almost a charcoal black material.
This black material absorbs heat from the sun, turning the moon's water ice into a vapor that accumulates like snow, falling on the trailing side of Iapetus. The result is the moon's distinct yin and yang veneer. Solar system. In volume, Saturn could hold more than 700 Earths. Composed mostly of helium and hydrogen gases, the planet has no solid surface, although deep within there is thought to be a dense core of metals. Despite its size, Saturn is astonishingly light, less dense than water. If it could be placed in an imaginary giant bathtub, Saturn would float. The planet's spin rate is also impressive. A Saturn day is only 10.5 hours long. This rapid rotation causes the planet to bulge out at the equator and flatten at the poles. Saturn's butterscotch exterior appears bland and calm, but this appearance is deceiving. Beneath the cloud tops is a churning cauldron of lightning and wind speeds that can reach over 1,000 miles an hour. At about every 30 Earth years, Saturn experiences a megastorm. Cassini had the good timing to witness one. This raging storm would grow to encircle the entire planet. Even more amazing is what can be seen at Saturn's poles.
Saturn has something unique in the solar system. It has a hexagon circling the North Pole. It's a 6-sided jet stream. You can almost imagine horses on a racetrack racing around the hexagon. We don't know why it keeps its 6-sided shape. It's some kind of a wave pattern that goes around Saturn, but it's very stable. It's been there for decades. It's about 2 Earth diameters across. At the very center, right at the North Pole, there's a giant hurricane. It's about half the size of the continental United States, with wind speeds about 4 times a typical hurricane force wind.
A second monster storm was discovered at Saturn's south pole. It is also ringed with towering clouds but lacks a hexagon. And while this vortex looks like a hurricane, it doesn't behave like one. These are just some of the wonders of Saturn witnessed by Cassini. But still to come, is an entirely different way to explore the planet as the spacecraft nears its end. By 2017, Cassini had circled Saturn more than 250 times. Cassini's original lifetime warranty was for 4 years at Saturn. The mission more than doubled that guarantee. In 2017, 20 years after its launch, the spacecraft was still performing beyond expectations. Yet Cassini's days are now numbered. It is running out of fuel. And before that happens, the spacecraft has to be set on a course that will ensure it will not crash into one of Saturn's moons that might harbor life. It's decided to end the mission by plunging Cassini into Saturn.
Flight Director redefined. We have lots of signal at X-ray band and Sierra band.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal 115546 for the S-band, so that would be the end of the spacecraft.